Hey there, welcome to Smoke and Science, the podcast put on by our team at Smoke and All, where two pharmaceutical scientists break down the research of cannabis and other natural products and how you can use this information in your everyday lives. I'm Miyabe.
And I'm Riley.
Everyone who has purchased cannabis at a dispensary has seen the cannabinoid profiles listed on the labels, but there's so much more than that.
Today, we are joined by Dr. Amber Wise, Scientific Director of Medicine Creek Analytics in Washington State and Chair of Programming for American Chemical Society's Cannabis Subdivision. Amber has her PhD in chemistry and is going to help us demystify the triumphs, trials, and tribulations of a cannabis testing laboratory.
Welcome to Smoke and Science. Nothing but the facts about our favorite plant.
All right. Well, it's been a little while since we all hung out in Las Vegas at the MJ Biz conference, which was so much fun. And Amber gave an amazing talk on how heavy metals could potentially leach into vape cartridges. Really interesting research from her laboratory. And I think if Amber is willing, she can give us a brief overview of what those findings were and what they mean for cannabis consumers.
Well, thanks for having me, guys. It's been really fun to get to know you over the last few months and years. So in terms of the aerosol research, I run an analytical testing lab. We sort of generally, our clients are legal cannabis producers and processors in Washington State. But I have a background in academia, and we have another PhD chemist on staff and an interested, management team that wants to make sure that we understand some of the fundamentals that aren't out there about cannabis and people's usage of it. And so we have the kind of interesting ability to do the research in our lab, just self-funded, essentially.
Some people say self-funded research is biased, but that's basically the entire pharmaceutical industry. And in my experience in cannabis, it can be one of the only ways to study things that are difficult to access. Research is expensive, so companies that dedicate resources to self-funding it and sharing it are top tier in my books.
So we looked at the metals content in the aerosol coming from just regular cannabis cartridges filled with concentrate or distillate that you might get at a retail store. They're popular sellers. We sort of had to narrow our focus a little bit just on one style of cartridge because there's so many variables, as we know, ways of inhaling and heating and consuming and exposing yourself to cannabis that, we really had to narrow it down to control some of the variables in the experiment. But basically what we found was that, if there are metals, that are in the heating elements or in portions of the cartridge that get really hot, they'll probably migrate into the aerosol that you inhale. And one of the important things to keep in mind is, at what levels are these coming off? And so, our experiments were 50 puffs were sort of one measurement, which, may be quite a lot for some people in a day. Maybe it's an average for heavy users in a day. I don't really know. But that's another big variable in some of these results is people's usage varies widely. So it's difficult to interpret this. I mean, I've already been talking for a couple of minutes and I barely even said anything about the results. So, at the end of the day, we try to compare the levels that we found to FDA limits for pharmaceutical inhalable devices. And, so the FDA has lots of different limits on things, but specifically for inhalable devices, things like asthma inhalers or things like that. If you make a medical device that, is under prescription, they have limits for contaminants. And so we compared those metals limits to those FDA limits, and they were under at 50 puffs a day. And so those would pass, right? This could be a medical device if it was, run through those standards. So, it's very interesting work. It's a little bit kind of on pause, on hold at this point. We collected enough data. Another, I think, interesting thing that we learned was the historical ways or traditional ways of collecting metals in vapor which chemists have been doing for many, many years. This is not new science. The traditional ways of collecting it, specifically in the lab, is generally by bubbling the gas through some sort of water that has acid in it. So it's water-based. We call that aqueous-based. So generally you bubble things through an aqueous medium that's, has some acid in it, or sometimes you pass it through a filter paper and collect and analyze what's on that filter paper. So we sort of...
So I have two...
Yeah, go ahead.
Oh, sorry. I just had two things I really wanted to jump in. First of all, I super appreciate that you compared your data to FDA standards, because essentially what your research showed was that at 50 puffs of the cartridge, there was less metal in that vapor than that it would pass under FDA for a medication. And that's really important, because I think that your research could be viewed as like, oh no, there's metal being leached into the vape cartridges, which there is.
Absolutely.
You found that there was metal.
There are graphs, so the first part of my presentations are generally, here's all the graphs where we show there's metals in the aerosol, and everybody, I can see their face in the audience, like, oh my God, they're like, throwing cartridges over their shoulder in the trash.
And then you go and dig them out because you're like, actually, that's totally safe. Right. So I really appreciated that when I saw your talk. And then the second thing an interesting thought was about bubbling aerosols through water containing an acid. If someone was, in theory, wanting to put the metal, get metal out of their gas phase, in theory, that's saying you could put lemon juice in water in your bubbler.
Right, but it turns out that cannabis vapor is very oily. It's a mixture of oil droplets and vaporous gaseous molecules. And as you know, it's a very complicated mixture, probably better than me even. And so bubbling through water, our first paper sort of showed that was not sufficient to collect the cannabis vapor. So we had to use an organic solvent, something like alcohol or acetone, or methanol, to make sure that oily stuff was getting dissolved, and whatever might be carried in those oil droplets or oily vapor was actually getting captured in our experiment, because those definitely are going into your lungs.
Okay, don't do that, everyone. That never mind.
Right, and so you don't
never mind.
But at the same time, it's very unsafe, right? To do it at not in a laboratory environment, for sure.
Right, don't put acetone in your bongs
Absolutely.
Either. That's also a bad idea.
No.
But what if you do that, all of the cannabinoids and terpenes will also dissolve, just FYI. If you are thinking of trying this, ignoring my safety advice, you won't get any cannabinoids or terpenes through either.
Just a terrible idea. Terrible idea.
Everything, basically it traps all of the aerosol, right? That's the idea for our experiment. So anyway, so there's some interesting implications in terms of laboratories testing cannabis aerosols, which we know is coming down the pipeline, particularly in Colorado and, probably other states to follow.
So is the hope that the methodology used in this data could be used by other analytical laboratories to start evaluating if there are heavy metal contaminants being vaporized from these cartridges?
So I will be the first to say that this is a very time-consuming and not high-throughput method. Gotcha. In order for it to be used at a commercial level, it's going to have to be improved upon. The efficiency is going to have to be improved upon. And certainly they have multiple port smoking machines. But at the end of the day, in order to make sure that we were getting all of the sample, we had to rinse the tubing, we had to rinse the glassware that everything was in, and make sure all of that went into the final product, because the vapor condenses on the surface of the tubing that connects all this stuff. It condenses on the side of the glassware. And if you're putting a vaporizer directly in your mouth, most of that is going directly in your body, right? It's not condensing on a lot of tubing, on its way to your lungs, right? You're directly putting it in your mouth. So anyway, There's a lot of variables at the end of the day. One of the papers is publicly available, open source, and I'm happy to email anybody the second paper for free.
We can link that open source paper right in the podcast here. And just another question. So most of these metal levels were below the threshold to be any concern by the FDA. Is there any concern that over time these could accumulate in the body and that could cause some adverse effects that maybe we're not seeing from the initial experiment?
The toxicology of that becomes really complicated again. One of my past lives worked in the area of toxicology and exposure to different environmental chemicals. And the way that inhalation, first of all, is very complicated. The chemistry in the vapor phase itself can change. And then, like I said, the cannabis vapor is a mixture of like oil droplets and gaseous molecules. And so those oil droplets will actually sort of stick in your lungs. And sometimes they get, there's a number of ways that your body can kind of break that down. And so, how our body is taking those up and how they're expelling it, right? Maybe you just cough it right back out in the big, like, sort of, so, there's a lot of variables, but I think, there's been a lot of rumor. I mean, I've sat in a number of scientific talks where people say, oh, we think these metals are leaching into the oil. We did also look at that. So if the oil sits in the cartridge for some period of time, like it will on its way to the store, once you buy it, you probably don't smoke it all the first day, hopefully. The oil sits in the cartridge, and if there are metals, that are in contact, like some of those will leach into the oil. But does that make it into the vapor? Not necessarily. The metals don't 100% necessarily all vaporize, or we weren't able to capture 100% of the metals that we intentionally put in some of our research oil. That's probably longer summary than we planned, but hopefully it's...
Oh, no, we love it. We love diving into the details. And I thought the paper was really cool, too, that you were testing just essentially empty cartridges. And if you were to just kind of hit an empty cartridge, if anything happened there, because I think everyone's probably guilty of doing that at some point where there's like a little like bubble left in that cart and you're like, I'm going to get this. And you just keep ripping it. And,
or you have the hair dryer, you have the hair dryer out and you're
even if it just lays on its side for a while and there's really no oil in the wick, right? Like some of that concentrate in there is very thick. And if it's cold outside, it's very, very, it takes a long time to sort of get down onto the heating element. We saw some huge variations in rates of vaping between different viscosities, and all of those cartridges have different size holes that go to the wick. I mean, there's so many variables to measure here. I wish I had millions of grad students.
Well, we appreciate all the research.
Thank you so much for sharing your research with everyone, and then also for funding it and doing it yourself. That is incredibly awesome.
Yeah. I want to, I'm, really lucky to work for this lab that is, owned by a Native American tribe. And they were generous to, not have me worry so much about making a profit at the lab and focus some of our efforts on, finding out some of these really fundamental things. And we're able to peer review publish this because there's just so little data out there about fundamentals in cannabis, because it's very hard to access cannabis. So
shout out to the Puyallup tribe. How a tubes chill up, which I hope I got right, is thank you in Twelshotzi.
One of the ways we were actually able to have THC on site is because Washington State has a research license available to researchers within the state. And what that allows us to do is have cannabis, THC containing cannabis, which is federally illegal, on our premises that is being used for this specific research purpose. So, all of those things came together. And then I took the opportunity that was granted to me to make that happen. But certainly it's very difficult for anybody who's trying to run a business. This is not, a business making
we
venture
know.
here.
Research.
But I didn't, one of the reasons I got into the cannabis space, kind of leaving academia was there's a huge need for good science to be done, and somebody has to do it. And it's still very difficult for academics to handle any sort of product that, people are actually buying and using. So I didn't want the opportunity I had to just go to waste. And I also wanted to thank the other chemists who did all the bench work. I was just organizing the project and editing, manuscripts, but Charlie McDaniel was a great summer intern that we hired, and now he's off to graduate school, sadly for us, but good for him. And Dr. Srinivasa Malampati also is the PhD chemist that, assisted with all the experiments and all the ICP-MS analysis as well.
Cool.
So
shout out
they
to
did,
them.
More hours of work than
That's
me.
awesome.
Seriously. All right. So I'm going to move on to, I just want to say that I'm going to move on to something that maybe will make us all feel a little bit safer. At some point when we were all hanging out in Vegas, Riley and Amber both have a background in toxicology. And in some ways, it was inducing paranoia in me. Well, we were talking about non-cannabis. We were talking about non-cannabis toxicology of like plastics and hormones and no, we can't talk about that because it was inducing paranoia. But what we are going to talk about, which is something that I think is really important, is all of the safety and rigorous testing that goes on in cannabis laboratories. Beyond just potency, let's talk about like the public health safety thing. Let's talk about the types of controls that we have on cannabis, because we do have quite a few different tests that happen if you're buying cannabis from a dispensary, medical, or recreational. Every state is a little bit different, but we're going to cover the bases. So do you want to just give us like the briefest overview of the basics?
Yeah, so we do a lot of testing, right? And it means there's a lot of different instruments. There's it's like a whole, what do you call those shows? CSI's worth of like laboratories of instruments. But they go into two buckets, right? The public health and safety bucket, which you were alluding to, and then the cannabinoids and terpenes bucket. People call that potency, and it's incorrect word. So I'm going to use cannabinoid. We can talk about some of the nuances of cannabinoids and terpene testing later maybe, but in terms of the regulations and the public health and safety measures, cannabis is one of, if you have a state that has rigorous requirements and you're purchasing product from a regulated store, it's way safer, in my opinion, than any vegetable you're going to buy at the store in terms of pesticide exposure, things like that. So we run, you mentioned that all the states have different rules. In Washington State, we are not currently required to screen all lots for pesticides or heavy metals. Most states that have legal markets do have that requirement. We're moving in that direction at a snail's pace. Please don't get me started on that this week. So some of the other tests, and people are relatively familiar with pesticides and heavy metals testing. Certainly one of the caveats of pesticide testing is, we don't know what pesticides do when they're heated and inhaled. Like there's no studies on that really. So the fact that we screen, material that will end up being combusted or heated and inhaled generally, is that a good measure? That's a conversation for another day. But we see very little pesticides in use generally. There's a list that is banned. Most states have a list. Some of the other tests, residual solvents is probably one of the least understood tests. Well, I'll get to the water activity next. The residual solvents is a measure for the concentrates that are extracted to make sure that there's not any dangerous solvents left over. In the regulated market, people generally don't use dangerous solvents. Butane is not something you should be inhaling at really high levels potentially. But if you've ever used a butane lighter to smoke a bowl, you've inhaled a lot of butane. So people freaking out over ppb levels of butane in cartridges should really calm down. But there's also, potentially other dangerous solvents that people could be using. But if you're in a legal market, with a license, those really just aren't occurring at this point. And then there's microbial screens. Different states require different groups of microbial screens. And that's just, microbes can be dangerous for sure if you inhale them. Certain ones more than others. We live in a soup of microbes, as we know. Most of them are harmless and many of them are beneficial, but some of them are harmful. And so, people who are using this as medicine and things definitely need to make sure they're not being exposed to microbial. And then the other one that's pretty misunderstood is mycotoxins. A lot of people who aren't scientists get those two mixed up, micro. If you're not paying attention or you're not pronouncing it clearly, it's very easy to mix them up. But mycotoxins, myco comes from fungus related. The word is fungus related, and it's molecules that fungus might produce. So it's not fungus itself, but there are specific molecules that are toxic to humans and other animals sometimes. And they're generally not found in cannabis products, which is good, but they are very dangerous. And so we do screen almost all products for mycotoxins in almost every state.
In that case, are you screening mostly for the organism that is capable of producing the toxin, or are you screening for the detection of the actual toxin? And I think we're talking mostly about aflatoxins here.
Yeah, so we're screening for the actual toxin molecule and not the fungus itself.
And those are primarily produced by Aspergillus fungi, I believe. As Amber just noted, mycotoxins are produced by microorganisms, specifically fungi in this case. One fungus that we talk a lot about in cannabis is the Aspergillus fungus because it's capable of producing these toxins called aflatoxins that can influence your liver in the way that it functions. Aspergillus is not unique to cannabis. It's actually found on many agricultural products, talking about corn, peanuts, tree nuts, and other products that are stored for long amounts of time. The different state regulations will determine what microbes need to be tested for before the cannabis products reach your dispensary shelves.
So that fungus is also one of the most common allergies. If you have an allergy to mold or mildew, if people know that you have a mold allergy, that's one of the more common ones. So it's something that if you do have a mold allergy, you should pay a special attention to, or if you just have allergies in general. But so cannabis is under a lot of testing, and it's all publicly available and very publicly documented if you buy it from legal states and legal, dispensary that's being regulated. And, that's something I was just having a thought about it because I bought I bought some salad dressing, and it was the best buy date was July of this year. So, I'm a good 5 months away from that. And it was bad. It was rancid. And I went and I was looking at it because I was just going to write them to report it and be like, hey, everything in this batch is probably also bad, likely. And I couldn't find on the salad dressing, there's no batch number, there's no lot number, there's no production, there's no metric trace. And if this were cannabis, I would have been able.
Oh my God. I mean, we joked when I worked for a licensee, producer processor, we'd have to make one of those little foldable books for our labels, that come on some drug packaging, right? Where you accordion pull it out with all of the data and info that we're supposed to put on these labels. And every state is different. And so when companies try to go, and have their brand in 4 or 5 different states, they literally have to have completely different packaging. And people don't think it's a big deal. But setting up your software for your labeler is not a trivial thing. And then, making it different in every single place that you operate it's a nightmare.
Sounds very difficult. And just to bring it kind of back to the microbes, so bacteria and fungi that could be on these on the flour that you buy or in products. That is pretty common. And for most people, it wouldn't cause any adverse effects to have small amounts of these microbes present. But there's a lot of people who use cannabis as medicine and they might be immunocompromised. So their body isn't able to fight off those microbes as well as someone who is completely healthy. And this is where it becomes super relevant for those medicinal patients to make sure that we're not exposing them to something that could cause more harm than good.
Yeah, absolutely. People have a tendency sometimes, I think, in this industry to sort of downplay those screens, oh, it's fine, it'll just pass, it's not really a big deal. But you're right, we should pay attention, and we don't see 100% passing by any means. Another test that is probably the most misunderstood test, this is the little science lesson for people for the day, that's related to microbial growth, is water activity. So in Washington, we're required to report 2 things related to water activity and percent moisture. And those, it's confusing, what's the difference between the 2 of those? Percent moisture, so the analogy I like to make, which is sort of an okay analogy, is, you always say, we're 70% by weight water, right? So that's percent moisture. Cannabis plants, when they're harvested, are also 70% by weight water when they're fresh. So that's a percent moisture. That's just the weight percent of the water there. But the water activity is the sweat that's on the surface of your skin. So it's just the available water on the surface of the product that microbes might be able to utilize and populate. So the higher the water activity, the more likely microbes can live there because they like moist environments. So the lower the water activity, the drier your thing is. Water activity is an old measurement that comes from food safety. And so that's why crackers and cookies don't grow mold all the time on your shelf, is because they're really dry. And there's just not enough, nice, cozy places for those microbes to.
I have to say that's probably my favorite analogy for water activity and moisture. I'm gonna have to say it. I'll be like, water activity is like the sweaty, like.
Me too. I love that.
The dew on your cheek.
The light upper lip moisture. One thing that I get that's interesting about water activity as a measurement for safety, though, is that cannabis is in many ways water activity and moisture content, both of them. In many ways, having some of that is not bad for high quality cannabis. And that brings us to a topic that we're going to touch on in the next section, actually. But it's something I just wanted to bring up that is really low water activity, like really, really dry bud is not necessarily good. Yeah.
It's not good.
But it's good, but it's safe. I mean, it's safe.
A non-zero number.
Right. It's safe in terms of microbes, but that's where cannabis is complicated. That's where it's one of the ways in which cannabis is really, really complicated. And I think another one of the ways that we wanted to talk to you about, because we're both natural products people as well, and you test all these natural products, and so firsthand that natural products, things that are created by living things, are incredibly variable. Just like every single one of us is different, every single plant is going to be different. And even with identical genetics, there's a ton of variation and variability. And I just wanted to see if you wanted to comment on that in terms of testing and control, quality control.
Yeah, well, it's something we deal with literally every day, both just thinking about how to control for some of those variables, conversations with clients about why our number is different from some other lab when they sent us, quote unquote, the same sample. I'm sure people who listen to this are relatively aware that the plant, like an individual plant, can vary in cannabinoids, if it's the top part of the plant or the bottom part of the plant that the bud is growing on. And then obviously just how it's handled after it's harvested. And then just the growing conditions alone. So, a clone, seller can sell 100 clones to 5 different growers, and they can, get 5 completely different terpene and, the cannabinoid profiles, if they all harvest at a similar time or similar maturity level, will probably be relatively similar in ratio to one another. But the terpene profiles, some of the other, molecules that we don't even screen for at this point, other secondary metabolites, other things like that, might be completely different if they're grown outdoors, if they're grown under stress, if they're grown under, there's insects pinching their little leaves occasionally, the temperature, the humidity. I mean, all of these things affect how a plant, what molecules a plant ends up expressing. And then you could also all harvest, the same lot and then take it back to your individual facilities and dry and cure and treat that flower quite differently as well. And so there's just so many variables here. And so when, we don't get these calls as much as we used to in terms of, I sent this bud to this place and that lab and your number doesn't agree. We get fewer of those calls now, but we do get some calls more about pesticides passing or failing at this lab or that lab. But in terms of the biological variability, it's all over the map. And certainly strain names are more or less meaningless. I'm not even going to go, hopefully we're all past using the terms indica and sativa. And that's just scientifically not a thing at all. And I refuse to generally let them escape my mouth unless I'm talking about how we shouldn't be using them, unless we're talking about the shape of the leaves. Really, that's it. And so the variability, even just, you buy Girl Scout cookies in Washington State, you buy Girl Scout cookies in California, were they even the same genetics to start with, is very unclear. And so then we also start to see the potential. I mean, so that's the complicated part of it. But one of the benefits I kind of see of that is the industry moving towards something like the wine industry, where there's terroir of different regions, right? And due to COVID, I haven't been leaving Washington State very much. And Washington has these interesting rules where we really don't have any out-of-state investors or multi-state brands here. So we're really isolated. And so I'm a little bit, unclear about some of the things that are going on in a lot of other states. But the variability, or so the strain names, if I go to a store in California, all the strain names are completely different than the ones that are here in Washington. And so there's already partly because of the state by state nature of this, we're creating each individual state and region will have specific, dominant genetics and certainly the climate and all of that, the soil, the water, all of that, has an effect. And so I'm hoping that that's a direction that some, more craft growers, and there will be a demand for niche markets like that to take advantage of some of that variability as well.
So when someone buys flower and at a dispensary and it has a certificate of analysis or a COA on it, and that's reporting different things that we just talked about, including things like the cannabinoids and terpenes, would you advise people to take that as an estimate because it wasn't necessarily like that nug that was tested in the laboratory? Like there is a certain amount of deviation that's completely normal and expected, but you could say it's within that range of plus or minus like 5%?
Yeah, well, yeah, there's a lot of factors that go into that. There's a lot of incentive for the labs to inflate those numbers knowingly or unknowingly. And I've seen cannabis labeled at 42% at stores in Oregon, or even in Washington. I hear about this all the time. It's like, that's not really physically possible.
It also sounds like a terrible experience to me.
So anyway, the point is, yes, it's absolutely an estimate. There's probably a range of plus or minus 20%, around that number, if not larger, of what you're actually getting. And then not only that is like, if it says it's 20% THCA in this nug, you're definitely not inhaling every single one of those molecules. And so, and then also the entourage effect. And I think this is probably like a segue into the, product or what is quality conversation is, when people don't see the number on the package and just, have an experience with cannabis, formulations or flower or concentrate that have different ratios of cannabinoids and different ratios of terpenes will often make you feel much more intense, physical feelings than ones that are just straight high in THC. Like straight distillate is the worst. It's like the Everclear of cannabis. That's not very easy to find straight distillate for a number of reasons, but
edible products. A majority of edible products are straight distillate. So edibles made with distillate will have a huge amount of THC with minimal other cannabinoids or terpenes present in the edible formula. For me, this gives me tons of anxiety, and for some other people, it seems to prevent them from being able to feel the edibles. If you're looking to try an edible that's not made from distillate, be sure to ask if it's made using a crude extract or if the edible is full spectrum and contains everything in the plant.
Yeah, you're absolutely right. And so, without all of these other molecules that the plant has, it is really easy to feel some pretty strong effects for some low THC flower that has an interesting terpene profile that kind of agrees with your constitution. Or even like a, not so great experience with a variety that you don't really enjoy.
Hey everyone, it's Andy here. One of the first things that I learned when I started growing cannabis was that the environment that the plants grow in is extremely important to the outcome that you get from that plant. And also that there is a lot of inconsistency in plants. Inconsistency, to be clear, is not a bad thing, and it's what we see in nature. And a lot of people prefer things to be in a natural form. That's something that we're excited about when we talk about flower. Flower is the natural form of cannabis. It is probably the oldest form that has been used by humans, and it continues to be one of, if not the most popular form sold commercially. So it's something that we're really interested in continuing to investigate, but it's important for everyone to recognize that there are some inconsistencies in the plant, and that's okay. I think it's what makes it so beautiful, and that each one of these experiences can be even better than the last or even different than the last. I actually talk about this exact subject pretty often and will be presenting it, which is pretty exciting for me personally. That's my first big presentation on anything really cannabis related, and it'll be at the Hereditary Neuropathy Foundation's Thrive Patient-Centered Summit on March 5th and 6th. Our slot is at 1 p.m. on March 6th, so if you're interested, take a look at the Hereditary Neuropathy Foundation's website for more information, and you can hear more about my thoughts on environment being probably more important than genetics when it comes to thriving, whether you're growing plants or just you as a human being. We're going to hear a review here next, and these are really helpful for us, so thank you all for continuing to leave them, and we will get back to the show in just one sec. Thank you.
This review is written by John Van Dyke, who says, as a bud tender, I'm looking forward to more episodes. Both speakers really know what they're talking about, and they have a great back and forth with each other, which makes it for easy listening. Thanks for taking the time to write a review about this podcast. We really appreciate it.
Now, a quick word from our company and sponsor of this podcast, Smoke and All, and then it's back to the conversation.
Smoke and All is a unique cannabis extract that feels more like smoking compared to traditional edibles. That's because it's actually extracted from cannabis smoke. Smoke and All can be incorporated into a variety of formulations, including edibles, tinctures, and capsules. And Smoke and All extraction is fast, easy, and requires very little upfront investment. If you work at a dispensary or are involved in cannabis processing and are interested in incorporating Smoke and All formulations for your products, contact the link below or send us a message on Instagram. Smoke and All. We smoked it for you.
So now let's talk about quality of products. And I know you've mentioned this earlier about entourage effect, the combination of effects of cannabinoids and terpenes, and what makes a higher quality product. And from my experience, I had a medical card in California before analytical testing was a thing. And back then, the quality of product was, from my memory of it, and to be fair, I also now moved across the country and live on the East Coast, so there's a lot of variables there. But the quality of product was very, very high. And before analytical testing, everything was just ranked as highs, mids, or lows based on pricing. And there were just, glass jars. You got to smell the terpene profile and you got to choose exactly what it was. And I wanted to ask you to comment on what you think about how analytical testing relates to that. You mentioned earlier, and I made the mistake of calling something potency, and it's something I'm working on changing. And I wanted to know, your thoughts on that.
Yeah, I mean, there are definitely advocates in the industry for grouping things like high cannabinoids, mid-level, low cannabinoids, right? There are lots of people out there that actually want low doses of cannabinoids, despite what the market might be telling us.
I'm raising my hand. We're raising our hands.
Yeah.
Right. And so, there's something to be said for that, right? We talked about the potency. See, the cannabinoid numbers on a C of A being an estimate, right? And there's a big variability that can be around that. So there is something to be said for just categorizing things as, higher concentration, middle concentration. But, the entourage effect, the terpene profile has a lot to do with that as well. And so, it's a little more difficult because we still don't quite understand the interaction of specific terpenes with one another and with our bodies. And certainly different people's bodies react to different profiles differently. But at the very minimum, having the main terpene profile available would help people who are paying attention make decisions on, oh, this was high in myrcene and I didn't really agree with it. Next time I might try something that's high in pinene. Right. Or, if you're actually paying attention and keeping a journal, writing these things down, because, there's a lot of complicated words involved with some of these labels and things. And it's hard to remember all of those details. So, that's something to think about. And in terms of quality, I spent a lot of time in Oregon in the cannabis market as well. My old company operated in both Washington and Oregon. And so I was back and forth quite a bit. And in Washington State, the rules are in the retail store, everything has to be packaged up tight, no open packages whatsoever in the store. If you open it, you bought it, you have to leave immediately. And in Oregon, it's the good old days of California medical, where there's jars. Pre-COVID, you could smell them all and make your decision on that and see them. And there were jars that had, smaller B nugs and larger A nugs. And there were different price scales. And so, I am a firm believer in being able to smell and what kind of smells you are drawn to will potentially be cannabis that agrees with you. It's not a guarantee, but it's a place to start. But it's hard to do that when you're in a store and everything's like in 2 layers of plastic.
I totally agree. And I mean, just looking when you walk into a dispensary, and if you're completely new to cannabis and you look up and see just a bunch of these strain names with a bunch of numbers, you're kind of like, whoa, okay, I'm going to pick the fourth one down. That's the second cheapest. Like, I don't know, you kind of just choose what's in your budget or what has a catchy strain name. It's not always for people, like if you don't know a lot about the molecules that are in cannabis, the pharmacology, it's really complex. And I kind of hope, as you said earlier, that the research starts moving towards doing that groundwork for the people so that you can say, this cohort of people that struggles with this specific illness reacted really well to this specific strain of cannabis that was high in this terpene and had moderate to low levels of THC. Just doing that research so that someone, bud tenders or anyone can say, okay, like I recommend this to you, or even in an ideal world, your physician could help you choose your cannabis strain.
That's a long future.
I'm an optimist.
Always an optimist. Riley said it was going to be federally legalized within a year. I think you said that.
It's still happening. Just couple more months.
No, what you said is absolutely true. I mean, I'm overwhelmed when I go into stores and I'm very knowledgeable. And so, yeah, the pretty looking labels and, we talked about water activity and moisture previously. You can't tell by looking necessarily how dry something is either. And so, it's hard. And then even if you find a strain you like, you go back to the store next month, is it even there?
It's the same thing with topicals or anything else too. It's marketing what's selling a lot of those products. Some companies aren't even reporting the amount of CBD that's in that topical, but people are buying it because it's either pretty looking or there's someone familiar on the label or just something with the marketing. And that's happening everywhere in cannabis. It's happening everywhere in anything you buy, but it's something to be aware of.
There's an illusion of THC, and water activity actually has to do with this too. But what both of you mentioned about being overwhelmed and then looking at the menu and seeing it, a lot of people and this misconception that the percentage of THC means that you're getting more bang for your buck, and that you want the highest percentage THC because it's extremely expensive. So when you're at a dispensary and you're dropping a lot of money, you're like, I want to get like the highest quality thing. And in general, people assume, or a general assumption is that has to do with like the maximum percentage of THC. And all of us here don't believe that is true. And the reason why I'm bringing up water activity and moisture content is because if you have a dank nug, if you have a flower that has a good amount of water and moisture in it, it is going to have a lower THC percentage because water weighs a lot. Water is a relatively heavy amount of weight. So in general, if things have a really high percentage of THC on a menu, I always assume that they are extremely dry and crumbly. That's my personal assumption. And it doesn't always correlate. It doesn't always correlate with that quality. But I think that's a difficult thing to communicate when people are new to to cannabis and it's expensive, like you said. And then there's just a million options.
Absolutely. And the terpene profile weighs something too. So if you have a higher terpene profile, there's going to be a couple percentage points less, most likely, of cannabinoids, just based on, how math works.
And you can see why people kind of move towards this indica sativa thing, because it is so complex that even learning the terms indica sativa can be really confusing to people. So when they learn that those terms, they say, okay, I've learned something about cannabis. Now I can go into a dispensary and feel educated. And a lot of bud tenders are still going to use those words as well. I still
every
use them
single bud tender I have talked to for the last 5 years. I've been talking about indica sativa as garbage for a long time. There's just more and more science coming out every year that says it's not a relevant way. And literally the first question I get asked every time I go into a store is, am I looking for an indica or sativa? Or maybe an indica or sativa experience.
But you can see from a bud tender standpoint that they have a line of people waiting to get cannabis. They can't drop down their pharmacology textbook every single time and say, all right, so let's learn about terpenes. And, there has to be a quicker way.
Yeah, the pharmacology's not there yet. Bud tenders aren't scientists. They have one of the hardest jobs, in my opinion, in the industry. Interpreting stuff that they have no training in to people who have even less training is very difficult. And they're under pressure to sell certain brands maybe, or even just sell higher priced products, right? And they get given samples by certain brands. And so they're probably more likely to, suggest those brands because they've actually tried them. So there's a lot of things that go on that they have to handle, and they have a line of customers waiting. So they have to do it quickly.
We're all different. So it's like someone comes to you with an answer or wants an answer, and your only answer is like, hey, it's trial and error. That's unfortunately where we're at. I personally think a great way to begin the journey is by grouping some of the smells of terpenes together, because some of the terps smell like similar to one another. So like piney, fruity, gassy. I think you've seen these on, there are now like entire brands built just on types of terpenes, and it's like fruity, floral, like sweet versus piney, and versus like gassy or skunky or like a heavy herbal smell. And like your nose isn't always right, but it can be a good judge, because terpenes are what you're smelling when when you're smelling it. That's the aroma.
Drug dogs don't detect THC, they detect terpenes.
Wow. That makes perfect sense, because cannabinoids are odorless. I don't know why
they don't smell.
I'm just thinking it would be really funny if like there were drug dogs nearby to have just pure terpenes and just like divert them for no reason. But
I'm told that's how they train them. It's just, terpene mixtures. They don't have actual, but I mean, I don't know how they train drug dogs. I've heard that, and it makes sense.
It does make sense. The cannabinoids are odorless. So how would they? So along this topic with the percentages of cannabinoids and how it doesn't always correlate for us and for many other people with the total effects, I want you to elaborate on earlier and I've heard you talk about it before at length about calling it potency and what the problem is.
Yeah, I mean, I don't know why the word is used necessarily in the cannabis space so incorrectly, but it is and continues to be. So potency means a very specific thing in pharmacology of how much of the drug that you ingest is your body taking up. And there are, known models of how to study that. And with cannabis, when we say potency, what we mean is weight percent of cannabinoids generally, or maybe the total milligrams of cannabinoids in that edible, right? That has nothing to do with how much your body is going to take up. So again, with a 20% cannabinoid, if you have 20% THCA in a flower, which is very high, by the way, naturally, and that's like a floor, I'm told, for people to sell in Washington State to retail stores. So if you have a 20% THCA, first of all, you have to convert that THCA to THC, presumably by heating it. Is that with a lighter? Lighters are all over the map in terms of heat and how you apply it. Maybe it's a vaporizer, a little bit more controlled, but those heating reactions and conversion reactions happen in the presence of hundreds, if not thousands of other molecules. And so there's all kinds of different interconversions. There's already papers out there about terpene interconversion and a little bit on cannabinoid interconversion and all these other molecules that get heated up, what happens in the vapor, and then how much of that are you inhaling? How much of that is going off the end of the joint into the room? How much of that are you exhaling? Your body is not actually uptaking. So the 20% THCA is basically a meaningless number. I mean, it means something. It's 20% THCA by weight in that bud, but that has nothing to do with how much you're going to inhale. So the term potency is completely inaccurate when you're talking about something like smoking a natural product, that it relies on a chemical conversion for you to feel an effect.
Totally. And the more water that's present, the lower the temperature of whatever heating, because water absorbs a lot of heat. So the more water that's present in the flower, the different temperatures that are present there. And yeah, I mean, these are things that are so ingrained. I mean, I use it regularly and catch myself. I didn't catch myself today, but I do catch myself using it. And I think about it even in terms of potency, saying the word potency to mean a more layman's term of effects, right? Like the not even the pharmacological like definition of potency, but the more standard definition of potency to say like stronger, like I feel it more.
I want to take a moment and say that if you're using the terms like indica, sativa, potency, strain, or anything else that you've heard isn't accurate or shouldn't be used, it's still okay to use these terms. We're all learning, and the legal industry is still in its infancy. We can all work on prioritizing communication and education among each other in a respectful way. We will eventually all be on the same page, or at least closer, but we're just not there yet. So be easy on yourself and others. The unique terms used in cannabis can be overwhelming and confusing, especially to new users.
Even that is not accurate when it comes to percentage of, say, THC or even percentage of CBD for that matter, because we still don't understand how these molecules interact with each other in the air and vapor, or even in the body, like in edible formats. And something that you mentioned that Riley and I both really passionately about, one of the first things we talked a lot about is that some people just don't even feel edibles. Some people just can't even absorb them. So in that case, it doesn't even matter if they have a 500. I've had people message me saying like, I've had a 500 milligram edible, which would like stop my heart.
50 milligrams would do me in. I can't imagine 500.
I have accidentally had a 100 milligram lollipop just without, I don't know why, I just like didn't read the wrapper.
Yeah, and it's like with any drug. I mean, there's very few examples of drugs out there that where everyone reacts exactly the same, right? And you mentioned this, we're all different. And so we're seeing that more in cannabis, and it frustrates people, but it's not any different than any other types of drugs, and so that's one of the hardest parts about giving people advice is, you're right, just start by, figuring out what works for you. My advice is, as with anyone, start low, go slow, but keep a journal, keep a little notebook. And write down the strain you bought, where you bought it from, what's the brand, what was the numbers if you have them, and then how it actually made you feel. And that might start you on a path of figuring out, if you're really interested in finding something that works for you, that would be the way that I recommend.
We love talking about keeping journals, especially if you have like the COA comes off in a sticker. Like that's really convenient to toss right in your journal. Mentioning the time that you're actually using the cannabis, the consumption method. It's all helpful. And I'm sure a lot of people who use cannabis daily, like many of us on this call, you don't want to trust your brain to remember what strain you used and if you liked it or not, because let me tell you, you're not going to remember it. So it's really helpful to write it down, take good notes. You won't regret it. And when you find like a really, really good strain, or if you find one that really, really is bad, you want to remember that to avoid it or to get it again, because it's going to, either from a health standpoint benefit you in some way, or from a health standpoint, you don't want to use that strain again. And I just also want to bring up something you were talking about with smoking cannabis. And I think that's conceptually hard for a lot of people to understand, that when you are combusting, lighting on fire, smoking it, it's completely changing everything. And the molecules you're inhaling are different than the molecules that were present in that nug that you looked at just before. But at the same time, I mean, thinking about lighting a log on fire, lighting anything on fire, does it look the same after? Absolutely not. It's completely changed due to that fire. Fire is really powerful. Heat is very powerful. And we don't know the full story yet, other than a lot of things are changing, and the things entering your body are not the same things that the plant was making, but they still have therapeutic value.
I think onions are a good example of that, because a lot of people know that like when you eat a raw onion, it's really spicy and can be like very unpleasant. But then if you eat like a caramelized onion, it's like, I mean, I also like raw onions, but anyways, I like all onions, but I think there's a place in the world for both raw onions and caramelized onions, but that's how powerful heat can be, right? Like it completely changes the molecules in the onion, and in a similar fashion that happens to cannabis.
Well, in my opinion, the place for all onions is the side of my plate. I will pick them out religiously, and I have for my entire life.
So, Amber, I'm just curious if all the work that we're putting towards the standardization of cannabis and understanding how to profile cannabis and to report on COAs, if this kind of methodology, if you think this methodology is going to be helpful moving forward with the legalization or decriminalization of psychedelics such as psilocybin-containing mushrooms.
Yeah, so we didn't get too much, any time really to talk about the lab standards and the testing standards. And the science behind some of that. And it gets complicated. And because it's been illegal, there's not an agreement necessarily on what methods to use and what labs should be accredited to. But in terms of, testing other types of, they're not plants, right? They're fungi. Psilocybin are fungi. There's other plants that contain potentially useful compounds that we put into the psychedelic bucket, shall I say. And so the instruments to measure those molecules are all the same instruments we already have in the lab. And a lot of these molecules, researchers have been analyzing the plant material and fungi for these molecules. So we already know how to look for them. But can I legally have some in my lab is another story. So I get, probably 2 calls a month. Like, are you testing mushrooms yet? And no, we can't. Like, you're not legally allowed to have them. I'm not legally allowed to have them. We're not legally allowed to exchange them. Right. So it's, and as you probably know, and maybe have already discussed on this podcast, legalization is very different than decriminalization. So even if we get a decriminalization or a specialized use rule in place, that doesn't mean that anybody off the street can walk into my lab and I can test their batch of mushrooms for them. There's a lot of kind of legal logistics behind that, but the science is, I'm not saying like we're ready tomorrow, but the methods to detect these active molecules are very straightforward, and we already have the instruments.
Well, thank you so much for discussing all these interesting topics. We've really enjoyed talking with you. And we're just curious. We've been doing this new thing where we're asking people if they have anything interesting just about what they like to do in their free time, or just something you want to share with the audience about you or your life. The mic is yours.
Yeah, well, thanks. I really appreciate the invitation to come on. It's been really fun. I could talk about this for days. But one of the other things I do in my free time is I'm a master garden volunteer. And the reason I bring it up, because I know your listeners are probably all over the place, there are master garden volunteers in every state, and they're trained to give science-based advice to home gardeners. So look up the Master Garden group in your area. They're all related to a university extension. And all of the advice that master gardeners give is supposed to be based on science that is regionally and biologically relevant for your region. So I was trained in Washington State to be a master garden volunteer. If you're a master gardener in California, you get a different training on the plants and pests and climate. So most master garden groups have like clinics where you can go and ask them all kinds of questions about your gardening or yard or houseplants. So I encourage people to utilize that resource in their area.
Well, Amber, thank you so much for being on here. Is there any specific place that our listeners can go to learn more about you or hear more things that you have to say?
My lab has an Instagram. It's Medicine Creek Analytics is the lab that I manage. We, don't put a ton up there, but we're working on doing more. My Instagram is only pictures of plants and flowers and nothing else. It's my personal Instagram. So I don't know if that's very useful to people, but the other kind of organizing thing I do in my quote unquote free time is I do programming and planning for the Cannabis Subdivision of the American Chemical Society. And so they have a website. It's www.cann-acs.org. And there's information. We do programming. And what I mean by programming is presentations and lectures at the national ACS meetings, and we're developing talks for people on career options for chemists in the cannabis space and things like that. So you can find more information. They are also on Instagram and LinkedIn as well.
I've attended one of the Cann ACS and given a presentation, and it was fabulous. It was a fantastic thing, and I very much so support people, getting more information and putting it out there. Both things.
Yeah, that's how we met, actually. So here we are.
And here we are now, exactly.
Thanks so much for joining us. We're happy this conversation has been useful. If you have any questions or suggestions for the podcast, please give us a shout on Instagram at SmokeandAll. Or if you're a processor who is interested in working with us, please email us at sales@smokeandall.com.
If you want to support us in our effort to destigmatize plant medicines, please review us on Apple or Spotify or wherever you listen to this podcast. If you already have, thanks so much. Extra special thanks to Telfer C, John Van Dyke, Tabs24, Gerson, someone from New Zealand, Surge Near, C5X2C, Cool Bean King, Sync1, James T84, Airbender Andy, CK Dascam, Pimental Portfolio, Maya 1722, LaPlaya 34, Beth in New Hampshire, Tony Rome, CJ Sloan, Old Geek 1, QD 1994, John the Bow, Absolutely, Felly Cab, Samsonite 55, Mr. Clean, LJM 420, and Layman Stupid App. They are our favorite sesh members who always pass it to the left.
Mad love, friends. Thanks for your support, and we will see you at the next Smoke and Science sesh.